Picture yourself standing under a clear night sky, gazing up at thousands of twinkling stars. You might feel small, insignificant even, contemplating the vastness above. But here's something that might blow your mind. We're not just floating in ordinary space. We're sitting inside one of the most bizarre cosmic anomalies ever discovered, a void so massive that it challenges everything we thought we knew about how the universe works. Welcome back to Beyond the Stars. If you're ready to dive into one of the most mind-bending mysteries in modern astronomy, hit that subscribe button and turn on notifications so you never miss our deep dives into the unknown. Trust me, what we're about to uncover will change how you see the night sky forever. When we think about exploring space, our imaginations run wild with possibilities. We dream of visiting distant worlds, meeting alien civilizations, maybe even traveling between galaxies. The reality, though, is far more humbling. Our fastest spacecraft, Voyager 1, cruises through space at roughly 10.5 miles per second. That sounds impressive until you realize that at this speed, reaching even our nearest stellar neighbor would take over 70,000 years. And that's just to get to one star in our own cosmic backyard. Even if we somehow invented ships that could travel at nearly the speed of light, we'd still face astronomical challenges. Crossing our own Milky Way galaxy would consume 100,000 years. And if we wanted to venture beyond, to actually leave our galaxy and explore intergalactic space, we'd run into something far stranger than just distance. About a decade ago, a team of astrophysicists made a discovery that sent shockwaves through the scientific community. They found that our galaxy isn't just floating in normal space. Instead, the Milky Way sits within an enormous cosmic void, a region where matter is mysteriously sparse compared to the rest of the universe. This isn't just some empty patch of space we're talking about. This void could stretch up to 2 billion light-years across. To put that in perspective, you could line up 20,000 Milky Way galaxies edge to edge and still not fill it. What makes this discovery truly unsettling isn't just the size of this void. It's our position within it. We appear to be located near its center, as if we're sitting at the bottom of a massive cosmic bowl. This raises some pretty profound questions about our place in the universe and whether the physical laws we observe here apply everywhere else. Scientists call this the KBC void, named after the researchers who first proposed its existence. When they published their findings, it sparked intense debate. The discovery seemed to contradict one of the fundamental assumptions of modern cosmology, that the universe should look roughly the same in all directions. After all, if the Big Bang scattered matter evenly across space, why would there be such an enormous region where galaxies are so much rarer? Think back to the moment of creation, when the universe exploded into existence nearly 14 billion years ago. Energy and matter should have spread out uniformly, like ripples expanding across a pond. This idea, called the cosmological principle, is crucial to how we understand the universe. It allows scientists to assume that the physical laws we observe here on Earth apply equally to distant galaxies billions of light-years away. But the KBC void suggests that maybe things aren't quite so uniform after all. Recent measurements indicate that within this void, the density of matter drops by about 20% compared to regions outside it. That might not sound dramatic, but on cosmic scales, it's extraordinary. For reasons we still don't fully understand, the universe has created a gigantic spherical region where stars and galaxies are significantly less common than they should be. Here's where things get really interesting. This void might actually help explain one of the biggest mysteries in modern astronomy, why the universe is expanding faster than our theories predict it should. Scientists have two different ways of measuring the universe's expansion rate, and they keep getting conflicting results. When they study nearby galaxies and supernovas, they get one answer. When they analyze ancient light from the early universe, they get a different answer. This discrepancy has become known as the Hubble tension, and it's been driving cosmologists crazy for years. Some researchers think the KBC void might be the key. Imagine you're inside a less dense region of space, surrounded by much denser regions beyond. The massive galaxy clusters outside the void would gravitationally pull on the galaxies inside it, adding extra acceleration to the universe's natural expansion. From our perspective inside the void, this would make the universe appear to be expanding like trying to measure the speed of a river while standing on a boat that's already moving downstream. But not everyone agrees on how big this void actually is. Some recent studies suggest it might be much smaller than originally thought, perhaps only 230 million light-years across rather than 2 billion. If that's true, the gravitational effects wouldn't be strong enough to fully explain the expansion rate discrepancy. The debate continues, with new observations from advanced telescopes adding more data to the discussion. Now, let's engage in some wild speculation. Imagine we had unlimited time and access to technology that could accelerate us to nearly the speed of light. What would a journey to the edge of this void actually look like? First, you'd need a ship capable of withstanding enormous forces and shielding you from deadly cosmic radiation. More importantly, you'd need patience, because even at incredible speeds, this journey would take millions of years. Let's say your ship accelerates gradually to avoid turning you into human paste. At a sustainable rate, you'd reach the edge of our solar system in less than 2 weeks, already moving at about 10% the speed of light. But here's where things get weird. As you approach half the speed of light, Einstein's predictions about time dilation start becoming noticeable. Time aboard your ship begins running slower compared to clocks back on Earth. At 90% light speed, every hour on Earth feels like only 26 minutes to you. Eventually, your ship maxes out at about 99.99% the speed of light. Going faster simply isn't possible. The speed of light isn't just a speed limit, it's a fundamental property of reality itself. Any object with mass would need infinite energy to reach light speed, and infinite energy doesn't exist. As you continue at this relativistic velocity, time dilation becomes extreme. What takes 4 years from Earth's perspective passes in just 3 weeks for you. After traveling for what feels like 3 million years aboard the ship, you finally reach the boundary of the void. Behind you lies the sparse region we call home. Ahead, space transforms. Galaxy density increases by 20%. Massive superclusters appear more frequently, forming chains and filaments that stretch across hundreds of millions of light-years. This is the large-scale structure of the universe, the cosmic web that connects everything beyond our local emptiness. But even reaching this boundary wouldn't answer our deepest questions. What lies beyond the observable universe? Is space infinite, or does it have an edge? Current measurements suggest the universe is geometrically flat, which could mean it goes on forever. If that's true, then somewhere out there, impossibly far away, there might be another region of space identical to ours, another Earth with another version of you reading these exact words. The truth is, we may never know what lies beyond our cosmic horizon. Light from the most distant objects will never reach us because space between us expands faster than light can travel through it. As unsettling as that sounds, it's a reminder that the universe is far stranger and more mysterious than we ever imagined, and we're just beginning to understand our place within it. So what do you think is really out there beyond the edge of our observable universe? Could there be another version of you somewhere in an infinite cosmos, living a completely different life? Drop your thoughts in the comments below because I love hearing your theories. And if this video expanded your mind even a little bit, smash that like button and subscribe for more cosmic mysteries that'll keep you up at night. Hit the bell icon so you're first to know when we drop the next one. Until then, keep looking up and remember, the universe is far stranger than we ever dared to imagine.